Students, in this video, we'll discuss section 2 of JEE Advanced Paper 2025. In previous video, we discussed the first section. Now let us look at second section. In this, the first question, let L1 be a line of intersection of two planes, plane 1 and 2. Let L2 be a line passing through P and parallel to L1. Let M denote the plane which is given here. Suppose L2 meets this plane at Q and R is foot of perpendicular drawn from P to this plane M. Now, we have to find length of PQ, QR. So we have to find Q and R. Then we can find the area. Then we can find angle between the two vectors. Okay. Now, first, let us find L2. Since L2 is passing through P, so we can write 2 comma minus 1 comma 3 plus lambda of L2 is parallel to L1 and L1 will be parallel to cross product of normals of these two planes. So let us do the cross product. So I, J and Q, and the normals are 2, 3, 1 and 1, 2, 1. So I of 3 minus 2, 1 minus J of 2 minus 1, 1 plus K of 4 minus 3 is 1. So the vector is 1, minus 1 and 1. This is L2. And L2 meets plane M at Q. So we can get Q. How? So from this equation, x is equals to 2 plus lambda, y is equals to minus 1 minus lambda, and z is equals to 3 plus lambda. And this point is satisfying M. So let us substitute in M. So 2 of 2 plus lambda plus minus 1 minus lambda and minus 2 of 3 plus lambda, which is equal to 6. So this is 4 minus 1, 3. 3 minus 6 is minus 3. If we send to other side, we'll get 9. And 2 lambda minus lambda is lambda. Lambda minus 2 lambda is minus lambda. So lambda is equal to minus 9. If we substitute it here, we'll get Q. So Q is equal to 2 plus minus 9, 7. And sorry, minus 7. And minus 1 minus of minus 9 is 8. And 3 minus 9 is minus 6. So the Q is minus 7, 8, and minus 6. Now, let us find R. How to find R? R is a foot of perpendicular, right? And we can find a line L3 which is passing through P and perpendicular to plane. So it is parallel to normal of this plane. Okay, so L3 is equal to, the point is 2 comma 2 comma minus 1 and 3 plus lambda of here. It is parallel to normal of the plane, which is 2, 1 and minus 2. 2, 1 and minus 2. So from this x equal to 2 plus 2 lambda, y is equals to minus 1 plus lambda, and z equal to 3 minus 2 lambda. Since this is a point on plane M, we can write 2 of x, which is 2 plus 2 lambda, and plus y, which is minus 1 plus lambda, and minus 2 of z, which is 3 minus 2 lambda, equal to 6. So first, 2 is 4, minus 1 is 3, minus 6 is minus 3, so it becomes 9 on the other side. And 4 lambda plus lambda 5 lambda plus 4 lambda 9 lambda. So here lambda equals to 1. So R is equal to 2 plus 2 4, minus 1 plus 1 is 0, 3 minus 2 is 1. So R is 401, and we know Q is equal to minus 7, 8 and minus 6, and P is equals to 2, minus 1 and 3. For first two questions, we have to find PQ and QR. So first let us write the vectors. PQ is equal to Q minus P. So minus 7 minus 2 is minus 9. 8 plus 1 is 9. And minus 6 minus 3 is minus 2. So magnitude of PQ is equal to root 9 square plus 9 square plus 9 square, which is equal to 9 root 3. And QR is equal to R minus Q. So 4 plus 7 is 11. 0 minus 8 is minus 8. 1 plus 6 is 7. And magnitude of QR is equal to root 11 square plus 8 square plus 7 square. 121, 64 and 49. So this is 14, this is 13 and 2. So this is root 234. So what is 234 actually? 234 is 2117s and 3 9 we can take 9 ones 9, 9 3 is 27. So 3 root 26. So first PQ is 9 root 3 and that is 2. So option is correct. And QR is not equal to 15. Now let us find area of triangle PQ. So area of triangle PQR is equal to half mod PQ cross QR. So let us find PQ cross QR. That is equal to IJQ. PQ is minus 9, 9 then minus 9. And QR is 11, minus 8 and 7. So I of 72 plus 8, 9 8 63, right? 63 minus 72. Once again, so 7963 minus 72. That is equal to 9. So minus 9 and then minus j of minus 63 plus 99. So we'll get 36. 36 and then k of 72 minus 99, which is equal to minus 27. And the magnitude is equal to root 9 square plus 36 square plus 27 square. If we take 9 common, we'll get 9 by 2 root 1 square plus 4 square plus 3 square. 1 plus 9 is 10, 10 plus 16 is 26. So we'll get 9 root 26 by 2. Or we can write this as, if we send 3 inside, we'll get root 234 upon 2. So that is the area. And there will be a 3, right? Yes. So we'll get 3 root 234 by 2. So option C is also correct. Let us find area of, angle between what? Angle between PQ and PR. First let us find PR. We know PQ is equal to minus 9, 9 and minus 9. And the PR, to get PR, what we'll do is we'll subtract R minus P. So 4 minus 2 is 2. And 0 minus of minus 1 is 1. 1 minus 2 is minus 2. 1 minus 2. Okay. Then, so the formula for angle between vectors is theta equal to cos inverse A into B by modulus of A into modulus of B. In this case, A is PQ and B is B. So we'll get theta equal to A into B. So minus 9 into 2 is minus 18. 9 ones 9 and minus 9 into minus 2 is 18. These two will get cancelled. By mod A. What is mod A? We know it is 9 root 3 and mod B is root 4 plus 1 plus 4, that is 3. So into 3. Now 9 and 9 gets cancelled. So theta equal to cos inverse of 1 by 0. So the answer is around here. So the final answer is A and C. Okay. Now let us look at question number 6. Here, let n denote the set of natural numbers. They denotes integers. Consider the functions f and g. So there are two functions. We know the g of n. Okay, this is regular thing. So first let us check whether uh, let us look at the functions g and f individually. So f of n is equal to n plus 1 by 2 if n is odd, right? We don't have to repeat this everything. So let us take if n is odd. That means it can take values like 1, 3, 5, 7, and so on. So then f of 1 is f of n, where if n is equal to 1, then it becomes 1 because 1 plus 1 by 2 is 1. 3, then it becomes 2. 5, then it becomes 3, and so on. So you'll get all possible values here. So you are getting all positive integers here. Let us look if n is even. Then f of n can take 2, 4, 6, 8, and so on. So f of n is equal to, if we substitute 2, then we'll get 4 minus 2 is 2. 2 out of 2 upon 2 is 1. 4 minus 4 is 0, so we'll get 0. And next to 6, if we substitute 6, we'll get minus 1. 8, then we'll get 4 minus 8 is minus 4, so minus 2. And 10, then we'll get minus 6 by 3, 2 is minus 3, and so on. So here we are getting for f of n, for f of x, the range is all the integers. So it is a onto function. Okay. Now what about 1 1 function? No, it is not a 1 1 function clearly because f of 1 is 1 and f of 2 is also 1. So it is not a 1 1 function, but it is a onto function. So clearly the option D is correct. Now let us look at G. What is the situation with G? Let me clear this here. Okay. So if n is greater than or equal to 0, then G of n is equal to 3 plus 2n. If n is equal to 1, 2, 3, and so on, all possible natural numbers which are greater than 0, we can take 0 here. So if we substitute 0, then g of 0 is 3. If we substitute 1, then we'll get 5, and then 7, and then 9, and so on. Now, if n is less than 0, that means n can take minus 1, minus 2, minus 3, and so on. Integers which are less than 0. If you substitute then g of n is equal to minus 12. So this becomes minus of minus plus 2. And this becomes 4, 6, and so on. Here we are getting all odd natural numbers, and here we are getting all even natural numbers. But since 1 is missing here, it is not a onto function. But here the g is onto, so option C is clearly wrong. Now let us look at g of f. Before g of x, let us look at f of x. Okay. So what about f of x? So f of g of n. Oh, sorry. Yeah, I told f of x, right? So not f of x, f of g of n. So for f of g of n, we will get f of 3 plus 2n when n is greater than or equal to 0, and f of minus 2n when n is less than 0. And then this clearly 3 plus 2n is odd, so we'll get n plus 1 by 2. So 3 plus 2n plus 1 by 2 here if n is greater than or equal to 0. And minus 2n is clearly even, so we'll get 4 minus 2n upon 2 when n is less than 0. So that is equal to 4 plus 2n by 2. So 2 plus n if n is greater than or equal to 0. And 4 plus 2n by 2, that is also equal to 2 plus n. So clearly f of g is 2 plus n for n belongs to integers. N belongs to integers. But for f, we just require natural numbers and we are getting all integers, right? Are we getting all integers? No, we are not getting all integers because uh, f of g has its domain as natural numbers. So if we substitute natural numbers, we are going to get only natural numbers. We are going to miss all the negative numbers here. So f of g is not on to it. So option B is wrong. Now let us look at the last option, which is g of f of n. Okay. Now g of f is equal to g of n plus 1 by 2 if n is odd, and if n is even, then we'll get g of 4 minus n upon 2. Okay. Now here, the critical value for n is minus 1. If n is less than minus 1, then we'll get all negative values for which the g of f is equal to, for all negative values, it becomes minus 2n, right? So minus 2 of n plus 1 by 2. Okay. And that is equal to minus n minus 1. If n is greater than or equal to minus 1, if it is 1, minus 1, then it becomes 0, and it is more than minus 1, still it remains positive. So we'll get g of f is equals to 3 plus 2 of n plus 1 by 2, which is equal to 2 and 2 gets cancelled, n plus 4. Okay. Now, if n is for the second thing, and this everything that we discussed here, the n is odd. If n is even, then once again we'll get 4 as our critical point. So uh, if n is equal to 4, then we'll get 0. Okay. And for positive, what we have to do is we should take values less than 4. So if n is less than or equal to 4, then we'll be getting positive values. So we'll write g of f equal to 3 plus 2 into 4 minus n upon 2, which is equal to 7 minus n. And so clearly, if n is greater than 4, all we are getting is negative things. So g of f is minus 2 of n, which is equal to 4 minus n upon 2. So that is equal to n minus 4. Okay, now, so if now let us write all the values here. So how to write the values? Let us divide this. Let us divide into 4 parts. If n is less than minus 1 and odd, then g of f is equals to minus n minus 1, right? So minus of n plus 1. N can take what values? Less than minus 1 in odd means minus 3, minus 5, minus 7, and so on. So minus 3 plus 1 is minus 2, so it becomes 2. Minus 5 plus 1 is minus 4, so it becomes 4, then 6, and so on. Okay. If n is greater than or equal to minus 1 and odd, then we can take minus 1, then 1, 3, and so on. These are the possible values of n. And for this, g of f is equal to n plus 4. So we'll get minus 1 plus 4 is 3, which is 5, and 7, and so on. Okay. Now, for this, if n is less than 4 and even, so n can take what values, sir? So it can take 4, 2, 0, minus 2, and so on. So for 4, we'll be getting 3, and for 2, we'll be getting 5, and obviously 7, and so on. So we're getting the same thing here. And now for this, n is even and greater than 4. So n can take 6, 8, 10, and so on. So g of f is equal to, if it is 6, then it becomes 2, 8, then it becomes 4, and 6, and so on. That's it, right? Yes. So if we look closely, what do you want here? Is g of f 1, 1 or not? So it is not 1, 1 clearly, because g of f of minus 3 is also 2, g of f of 6 is also 2. So it is not 1, 1. So I agree till here. Now let us look at 1, 1 on 2. Are we getting every value? No, we are not getting every value here, right? So g should take all natural numbers, but we are not getting 1. So this is clearly not on 2. So I agree with the second statement also. So the answers are A and D. Now let us look at the last question of this video. Here, let R denote the set of real numbers, and Z1 and Z2 are two complex numbers. S is a set of order pair x comma y which satisfy the given condition. Which of the following statements are true? Okay. Now let us solve this equation. So modulus of x plus iy minus z, which is 1, minus 2y, equal to 2 modulus of x plus iy minus z2, which is 3y. So modulus is nothing but the root of x minus 1 whole square plus the imaginary part, which is y minus 2 whole square, equal to 2 root x square plus y minus 3 whole square. If you do squaring on both sides, you will get x square plus 1 minus 2x plus y square plus 4 minus 4y equal to 2 square becomes 4. So 4 of x square is 4x square plus 4 into 5 minus 3 whole square, which is 4y square plus 3 square is 9, 9 4 is 36, and minus 6y. Minus 6y into 30 is minus 12. That's it, right? Okay. Now, if you send everything to right hand side, you will get 4x square minus 3x square. X square is 3x square. Then 4y square minus y square is 3y square. And minus 2x becomes 2x. Minus 12y plus 4y is 8y. Wait, let me look at this properly. So y minus 3y square is y square plus 36 minus 6y. 6 4 is 24, right? Not 12. Okay. So minus 24y plus minus 4y becomes plus 4y. So you'll get minus 20y. And then 36 minus 5 is 31. We don't have to check for any other conditions that this is a circle or not. Clearly, in every option, S is a circle. So we just have to find the center and radius. Center is nothing but minus g by a comma minus f by minus is f by a. So in this case, g is 1, so minus 1 by 3. F is minus 10, so it becomes 10 by 2. This is our center, so option A is correct. And for radius, there is a formula root g square plus f square minus ac by a, which is equal to root 1 square 1 plus f square is 100 minus 3 into 31, 93 upon 3. So 101 minus 93 is 8. So that becomes 2 root 2 upon 3. So the radius is 2 root 2 by 3. The answer is A and B. So that's it for this video. We'll discuss section 3 in next video. So subscribe and stick.